This is a severe weather briefing for November 4th, 2022. The Storm Prediction Center has an enhanced risk of severe weather across parts of Texas, Oklahoma, Arkansas, and Louisiana in their first day 1 outlook, and this does include a 10% hatch tornado risk as well as enhanced wind damage probabilities. So you can see within there the potential for several tornadoes, some strong tornadoes as well. And to look at what's coming together to support this risk, we're going to first start off with upper air observations from 0Z. This was several hours ago, showing the main feature of interest. A long wave positively tilted trough over the western US, and from the base of that, we're going to see a shortwave trough develop, and that's going to be a big player in the severe weather risk today. And that is shown here on the forecast models. 500 millibar heights and winds. You can plainly see that feature right down here. That's going to be the developing shortwave with the axis noted there. As we move into the morning hours, that does transition into the afternoon. We see more of a neutral tilt on it with an amplifying mid-level jet streak on its eastern periphery. That is going to be coincident with shortwave amplification as well. Because as you see here, we play this forward even into the night, toward the end of the forecast period. Now we're dealing with a negatively tilted bowling ball of energy, basically, with very strong mid-level flow with that jet streak right over the Midwest. And we can see that again here with mid-level relative vorticity. This is showing that compact nature of the shortwave as we head into the afternoon and the evening. Most of that energy in the central part of the shortwave is still over the Texas Panhandle, parts of southwest Kansas, but we do see that storms initiate to the east of it. That is what's causing that anomaly. Now, these dynamics are going to result in more concentrated surface low development. So what we see here initially is an elongated area of surface low pressure over parts of Texas, Oklahoma. That is going to be deepening as we head into the afternoon. As you can see here, we play this forward into the afternoon here. It's still a bit elongated, but then it becomes concentrated. We see these circular isobars. That means the pressure is lowering, and it could lower quite a bit. And when that happens, you're going to get some better moisture and temperature advection. And we can combine those two properties essentially in what we're looking at here, the surface theta E. So where this is increasing, temperature and or moisture is increasing. And we see that axis of theta E advection right in through here, right across East Texas into parts of southern Oklahoma. That is where things are going to be starting to get unstable in the afternoon. And play that forward, it still continues. As a consequence of the surface low, the pressure falls right up here. That's going to advect this air mass northward and provide for destabilization. Especially when we consider the mid-levels as well. We do have some modest lapse rate steepness come in. But you can see the result of that head into the afternoon. We have an axis of mixed layer CAPE, which is on the order of 1,500 to 2,000 joules per kilogram. That's pretty good for the time of year, and that's really going to be providing energy for these storms, vigorous updrafts that strengthen fairly gradually in the early afternoon hours. Now, another important ingredient is wind shear. This is the 0 to 6 kilometer bulk shear, essentially, what we're looking at. And we see here, ahead of the shortwave, the increasing mid-level flow is going to support southwesterly bulk shear vectors that are amplifying to the 45, 50, and as we head further into the evening, even 60 knot range. You see, we play that forward to Arkansas, Missouri, northern Louisiana, amplifying up to about 60 knots. That is strong, but do keep in mind the southwesterly vector orientation. That's going to be something I mentioned here in a moment. But also, we're going to note the low-level storm relative helicity. This is 0 to 1 kilometer SRH, and that is essentially accumulated vorticity in a portion of the atmosphere. Now, we start off at 0 to 1 kilometer values already fairly high in this area during the morning because we do have these strong wind fields from the storm. We do have the strengthening wind fields, but that's really going to amplify in the afternoon. And when we see these normally start to weaken during the afternoon hours, they're not. We do still see some pretty decent values of SRH, 150, 200 meters squared per second squared. It could be higher depending on which model you use, but there is some disagreement at this point as to the magnitude of SRH. Still, though, fairly large values we're dealing with here, and this is co-located with that instability axis. So we do have an overlap of instability and low-level wind shear. And as we play this forward into the evening, it does amplify even further because the wind fields are really starting to ramp up. That low volt jet is intensifying such that right in through here, as we head into the night, we could see values 200, 300, even 400 meters squared per second squared. So that's going to be providing a continuing risk into the overnight hours. Now, the triggering mechanism is very interesting in this case because what we see here, this is College of DuPage. The surface low is indicated right here. The cold front extending down roughly through this region. That is going to be 850 millibar streamlines and relative humidity. Now, what you do note right here is that we do have some slight streamline convergence over parts of East Texas, southern Oklahoma. That is where we have that theta E advection. Temperature, dew points advecting. The pressure is starting to fall here, and as a consequence, the air is kind of coming together in this confluent pattern that could initiate storms in tandem with that moisture and warm air advection. And what does the environment ahead of this look like? Well, this is an example from the rapid refresh model, and it does note some important things. Number one, that moist layer, which deepens during the day, is very high relative humidity, which means we'll have low cloud bases. Also, we're going to have little in the way of inhibition, but also a lot of cloud cover and probably some showers going on pretty early in the period. But very high dew points, up to about 70 degrees, are expected in this kind of environment, and very low cloud bases with some pretty decent instability here. Cape profiles a bit thin, but better than what we had recently, so updraft potential is there. Now, the hodograph is seen here. We do have that enhanced curvature in the 0 to 1 kilometer layer, that enhanced length, which translates to stronger storm relative velocity. And again, depending on the model you use, this does vary and could be stronger. But I do believe the NAM is a bit of an outlier in this case, so I'm not exactly putting a lot of faith into that. But the key idea is here. We have modest instability, moderate instability actually. We have enhanced low-level wind shear. We've got low cloud bases. We've got organizing deep layer shear. And that comes together to support a parameter space which does appear conducive to severe weather. So we're looking here at the HRRR model. This is 00Z run. This is one interpretation of what the radar might look like as we head into the afternoon. So we're going to start off here with some frontal activity in Oklahoma and Kansas, and some prefrontal activity here. That's with that moisture advection. Again, cloud base is low. We're not going to have a lot of lifting to get these showers go, so that is not surprising to see. What we're concerned about is what happens later in the afternoon. As we do get that destabilization, and we do have that wind shear maintained, this is showing the potential for some semi-discrete supercells. I noted the southwesterly shear orientation earlier, I believe. Relative to that initiating confluent zone, that might support some clustering here. So we're probably going to have convection kind of cluster. These storms are going to be semi-discrete, have some convective interference, and that's probably going to, that's a good thing because it's probably going to limit the tornado threat to a degree. But the fact that we do have that kind of environment with the enhanced level shear, it does mean that we do have tornado risk developing in this area. In particular, I would say probably this zone right in through here, you could have some stuff develop with some pretty serious storms, including the potential for several tornadoes, perhaps some significant tornadoes, depending on how we get these storm interactions. That does grow up scale as we head further into the afternoon toward the evening hours. Continuing into East Texas, parts of Southwest Arkansas could have a strong tornado threat depending on storm mode. Also, we've got the frontal activity developing right back here. As that shortwave kicks off into the Midwest area, the cold front is going to accelerate, and as it does so, we're probably going to see that a linear mode takes place later in the night, some more clustering across Arkansas, southern Missouri, Louisiana, continuing into possibly parts of Mississippi late. And that's going to be mainly a wind damage threat, but you will certainly have an embedded tornado risk as well, as that uplift and convergence does amplify along cold front. So this has been a severe weather briefing for November 4th, 2022, as an active day of severe weather does look like it could be on the table today.